Hello everyone. Today we are going to present assignment 1, which is the Field Track Plus program code. So my name is Ting Guan and my teammate is Kam Chong. So this is the Field Track Plus program code. Okay, first these are the library that we use in this program. And we need to declare the constant for the program first. So we declare the field prices for the program and maximum liter limit and the number of store transactions, so that this all the constant will not change, which is fixed for throughout the program. And next is we use the parallel array. Parallel array means that all the array use the same index, which is the maximum history here, which is 5. And we also use the array to store field type and display prices. And now here we used field type and field prices array to store up to 3 type of field and 3 type of prices. And this is the function for the field price table. This will display all the field price. Okay, so next, this is the function for the transaction into the history. So we use the array for this function. And next, this is the function for the transaction history. So this we will have the store transaction history up to 5, which is the array size up to 5 only. So when the transaction history is more than 5, it will not store in this history. And this is the main function. So first of the main function is display the main menu, and this is the menu input validation. And there are 4 options, and option 0 is exit program, and option 1 is buy field. So for the buy field option, when we apply RON 95, so if the type is type 1, the maximum liter will be the will be 10 liter, which is this constant RON 95 motor, because type 1 is motor. And we choose the type 2 means that we choose the car, so the maximum liter will be 25 that we store in this constant. And other than this, will be maximum liter will be 60. So this is the maximum liter loop. That means when we input is more than the maximum, so we have to input until less than maximum. So this is the code to check the eligibility. And then we'll print out the receipt. This will calculate the total of the prices, which is the liter times the unit price of the field. So, and then the last will be displaying the receipt for the field, liter, unit price, and the total. And then if we select the choice 2, this will show the transaction history. And if choice 3 will show the field price table. So that's all for this code. Okay, now I will present about the reflection of the program. So the most difficult of translating the pseudocode into C++ was handling the conditional logic for field subsidy, eligibility, and maximum field limits. This was because multiple conditions had to be checked to determine the correct field type and applicable limits for different places. In pseudocode, conditions are often written in a simplified manner, but in C++, the logic needed to be implemented using precise if-else, if, and logical operators, ensuring that the code field price was applied based on citizenship status, vehicle type, and field type require careful attention to avoid logical errors. Breaking down the program logic into functions help improve understanding and debugging of the code. By separating tasks such as displaying field prices, saving transaction history, and showing transaction records, the program became more organized and easier to read. When an error occurred, it was easier to identify which function was responsible instead of checking the entire program. Several control structures were used throughout the program. If and if-else statements were used to determine field eligibility, pricing, and validation rules, while loops were used to repeatedly prompt the user until valid input was entered and to keep the menu running until the user chose to exit. These control structures ensure that the program follow the correct flow and handle invalid inputs safely. Array manipulation was used to store transaction history data such as field type, liters purchased, unit price, and total cost. By using parallel arrays, multiple transactions records could be stored and displayed after later without overwriting existing data. The program limits the transaction history to a maximum of 5 records, ensuring organized storage and retrieval of past transactions. So these are the reflections of the program. So next will be Appendix A, will be presented by Kam.
Okay, now I'm going to talk about our Appendix A. So open the file. Okay, so this is our code when he runs. We got 4 choice, 1, 2, 3, and 0, and this is output for the options 1, enter the new field transactions. So as you can see, the code is runs completely. First, we enter field choice, and then we ask the status of the citizen to check the eligible. Then we let user to select vehicle type and enter half of liters. Then scroll down. And finally, we will output the receipts. Okay, next. So for options 2 is view transaction history. The user, before he do a few transaction, and the history will store in this array. So you can see from the picture. Okay, next. Okay. For option 3 is display fuel price, and we create a table that can display the fuel price table as shown in the picture. Next. Okay, for the option 0, we will exit the programs and we will break the codes so that the running code will end it. Okay, next. Okay, this is scenario when transaction history is full. So we made a scenario when we enter the 6 transactions. The 6 transaction history will show that the history full, and it will not store in the transaction history, just as the pictures. Okay, next. Okay, this is scenario for when eligible for RON 95 subsidized. When must eligible for RON 95, the Malaysia citizen, the status must be yes. The user must be a Malaysian citizen so that she is eligible for RON 95. So our code is have made this so that when user he identify as Malaysian citizen, he will get the RON 95 subsidized. Okay, next. Okay, also same with the diesel subsidy. When user he identify as Malaysian citizen, he also get a diesel subsidized. And now is the non-eligibles. Okay, here got few conditions, such as if user is not a Malaysian citizen, he cannot eligible for RON 95 subsidy and diesel subsidy. And also, if users his vehicle is not motorcycle or private car, which is other vehicle types, they will also not get subsidy for the RON 95 and diesel. And our code, as you can see on the picture, we got show it. Okay, next. Also, this is the non-eligible for diesel. I already talked before. Okay, next. Okay, this is okay. These are the same as the non-eligible for diesel subsidized. Okay, next. Okay, for last scenario is that user inserts invalid inputs. As you can see, we enter choice wherever user input symbols, negative number or alphabet for input that must be numerics. We will let user to re-input again, just show at the picture. Okay, we got choice, field choice, the status of Malaysian citizens, vehicle types, and amount of liter. All these input we do a validation so that user would not input wrong thing so that the code will run smoothly and completely. Okay, that's all for the scenario. Now we move on to Appendix B. Okay, we got list of prompts. For the prompts ones, we asked ChatGPT to know how to use parallel array in C++ so that to store 5 recent transactions and update them when a new transaction is added. So ChatGPT give us a clear and completely solution for us. So it helps us a lot. Okay. So this is like a summary. We ask how to use parallel array, and the summary is parallel array store transaction detail at the same index. So new transactions are added until 5 records are reached. When full, older records are shift left, and the newest transaction is stored at the last index, so that it always ensures only the 5 most recent transactions are kept. So which part was used or modified? This parallel were used to store up to 5 transaction records. The program inserts transaction sequentially and prevents additional record from being stored once the historic limit is reached. Right, next. Okay, for prompt 2, we have asked how to validate numbering input so that user only inputs numbers and avoid infinity loop so that the program will not run forever. And also ChatGPT also give us solutions. Okay. So a summary is to validate some numbering input in C++, check for the cin fields and value range, clear the input error state, use cin clear, and discards invalid input from the buffer, which is used cin ignore, and reprompt the user. So this is prevents invalid inputs and also avoids infinity loops. So which part was used or modified? This is used to implement input validation in all user input sections of field tracks. So including menu selection, field type, nationality, details input, and vehicle time sections. Okay, next. So the last prompts. So is how to structure the subsidy eligible logic so that the user will get the subsidies when he inputs a correct condition. Okay, so ChatGPT also give us some solutions. Okay, for the summary, subsidized eligibility logic, check field type, nationality, and vehicle category in order. So it will apply subsidized price only when all conditions are met and default to market price otherwise. So when keeping the logic structure and clear, will help prevent the user get pricing errors and also improve the code readability. So what was used and modified? Eligible checking logic was implemented to ensure correct pricing and appropriate user messaging based on field type, nationality, and vehicle category. All right, that's all. Thank you.